going to talk about audio right now. That's one of the big important parts of this AV class is working with audio. We're going to give an introduction now and just tell you a little bit about how audio works. We can't go into video until we've talked about audio because video uses both. Come on. First thing we're going to talk about is what audio means. Basically, audio is of sound or the reproduction of sound. What it really talks about is what the human ear can hear. Now, of course, we know dogs can hear different pitches and stuff like that, but we're going to talk about what the humans can hear because that's what we are and that's what we work with. Approximately 20 hertz to 20 kilohertz is what people can hear. That's 20 hertz to 20 kilohertz. It's not a bad idea to memorize those numbers because that's going to be important throughout this class. Sound waves, we're going to talk about what they are and what we can hear with them. We're also going to be talking about the different components of sound equipment and how we use that kind of things. One important thing to know is that sound waves are also called acoustical energy. If you're talking about the physical side of things or you're doing things in the scientific side, sound waves are basically that acoustical energy. All right, first off, how sound waves work. Sound waves are basically a variation in pressure. So you see ripples in water, you see all that kind of stuff. Well, sound waves are variations of pressure in the air. So as an object vibrates, it causes the air around it to shake as well. That vibrating sound, that vibrating air, hits our eardrums, and our brain is like, hey, that's a sound. So we hear it, and it translates that into things that we can hear. Sound waves travel through the air the same way water waves work in water. Those waves are easy to see and easy to understand, so that's kind of a good way to illustrate it. Although sound waves, instead of just rippling out in one direction like water does, it goes out in all directions. So that's a pretty cool thing. Sound waves are also put on a graph. We graph them, and that's called a waveform. It's like a two-dimensional vision of what a sound wave looks like. But in reality, like I said, it goes all around, everywhere. So that's one of the important things we need to know is that's what a sound wave is. That's what we hear is literally the sound wave. Now, the sound waves have certain properties to them, and the three most important ones, and the ones we're going to talk about and work with, are first of all, wavelength. Wavelength is the distance between any point on a wave and the same point on the next wave. It's literally how long the wave is. So if you measure from the peak of one wave to the peak of the next wave, that's your wavelength. You can do the same thing with the valley, the very bottom of it, or right in the middle as well. You measure that, and that's called wavelength. The next thing is amplitude. It's from the bottom to the top. That is the strength or the power of a wave. It's how loud it is. That height of the wave is viewed on a graph, and that is our amplitude. Higher amplitudes equal higher volume. That's why we call an amplifier something that makes the noise louder. Frequency is the next thing we're going to talk about. Low frequencies is when you have a whole lot of space between the peaks of the sound waves. High frequencies are when you have really close together sound waves that are pushed real close together. The number of waves in a second, the number of times a wavelength occurs in a second, is the frequency. That's measured in kilohertz. Higher frequencies, higher pitch. Lower frequencies, lower pitch. It makes sense, right? Higher pitch, lower pitch. That's your frequencies. These waves, though, they don't exist just in a vacuum on their own by themselves. They actually interact with each other. There's a couple different ways they do. It's called phasing. If you have things that are in phase, that means they are the exact same sound wave, same shape, same everything, same wavelength, same amplitude. It's all the same frequency. Those waves add together and make a louder sound. It's like if you have one speaker that's playing noise, playing a song, and then you put another speaker over there playing the exact same song, it's going to be louder. It's because those two speakers are making the exact same wavelength, and it makes for a louder sound. The other one is 180 degrees out of phase. That's if you take it and just flip the sound waves over. Now, you can't do that physically. It has to be done electronically. So you take a wire and you run something, and you have another wire that comes through and runs the sound and flips it over 180 degrees. That makes silence. If you have noise-canceling headphones, or if you have ever seen a cable that is called a shielded cable, basically what they do is they record, those headphones anyway, they record the things that are going on in the environment outside, and then they flip that sound signal upside down and play it back into your ear. That right there is using that 180 degrees out of phase. They flip the sound over, cancels the noise out, and all you hear is what you want to hear. That's how 180 degrees out of phase is working. Then you have what's called different waves. The waves don't match up exactly. They're just there. Well, that just makes a new wave, a new garbled wave, so that you can hear all the other stuff that's going on around you. So that's sound waves. Sound systems, real quick. This isn't hard to do. It takes 3 things to make a sound system. You have to have two transducers, and an amplifier. So what that basically means is you have to have something that makes the sound louder, and then 2 things that can broadcast and receive the sound. An example of a transducer is a microphone. Microphone is one type of transducer. That means it's taking the waves that you're sending in with your voice and changing them into another form of energy. So it takes that acoustical energy we talked about earlier and makes it into electrical. So once you get that electrical energy in the amplifier makes it bigger, makes it louder, makes the sound more. And then once the sound is made bigger electrically, it's brought to another transducer, which is the speaker. And then that speaker puts it back out as acoustical energy. It translates it back from the electrical energy, puts it back out as acoustical, makes it louder. You can build from there. You can make your sound system a whole lot more. You can put in equalizers, recorders, playback, processors, change the sound up, all kinds of different ways. But the basic thing you need to know is that it takes 2 transducers and an amp to make a sound system. That is simply a mic, an amp, and a speaker. That's all you have to have. Now you can substitute the mic, take the mic away, and put a CD player there, or an MP3 player, or whatever, and then you have an amp, and then you have a speaker. That's still a sound system. That is the basic overview of audio. We'll be talking more about this in class. We'll be using some things. We'll go over questions and stuff like that. But anyway, thank you for listening.